So I'm going to try and solve this question here on the board. Can you please tell me where am I making my mistake? Log A plus log B, yeah. So log of 5x equals 2. The inverse is log base 10, so I'll do 10 to the power of on both sides, which leaves me with 5x equals 100, x is 20, x equals plus or minus, hang on a moment, no, that's it, isn't it? X equals 20. Okay, so what have I done wrong? Well, my mistake has come straight at the beginning. Okay, so our rule is that if we have log of a base of A plus log of the same base for B, and we are adding them, much as we are here, well, this is going to be equivalent to log of AB. So the product of them rather than adding them together. Okay, you can test this out for yourself. In fact, if you try something like log 10 plus log 100, log 10, if you type this in your calculator, or if you just think about it, what power of 10 is 10? It's 1. What power of 10 is 100? Is 2. And notice that if I multiplied them, that would be the same as 1,000. And what power of 10 is 1,000? It's 3. So if you forget, you can quickly sort of work that one out for yourself. But it really must sort of be as we've done there at the top. Okay, so it needs to be log AB. So let's try it again. So instead of doing this step here, which I'm afraid is just wrong, we should be saying that log of 2x plus log of 3x is equivalent to log of 2x times 3x, and then equal to 2. So log of 6x squared is equal to 2. Then the other steps that we did was generally good. Okay, it's just the numbers are going to be different now. So 10 to the power is the inverse. 6x squared is going to be equal to 100. X squared would be equal to 100 over 6. X would be equal to plus or minus the root of them. So root of 100 is 10. 10 over root 6. Something to bear in mind is just because you have these values here doesn't mean that they will both work. In fact, one of these will not. If you try typing these in up here, you're going to have a problem. So the positive is going to work, but the negative is not. Because when you substitute it into, in this case, either of them, but in general, if it causes a problem anywhere when you sub it in, so if you have log of a negative number, which is what I've got here, that's going to happen, it's invalid. So we need to ignore that solution. Just because the algebra gave that solution doesn't mean it's a solution to the original equation at the start. Okay, so another thing to watch out for there. But the main idea here is we need to make sure we're using our rules properly. Now, let's have a go at another question. So this time, what should we do? Have a quick think about it just for a moment. Well, this is log of something A. This is plus log of the same base B. So we're going to use that rule one more time. So let's do that. So log base 2, you might want to do a big pair of brackets on this one here. Let's do 2x minus 1, not plus, but multiplied by x minus 3 equals 5. Now you could expand this bracket, or you could just keep it like that for the moment. 2, the inverse of log 2 is 2 to the power of. Let's do that. I'm going to get 2x minus 1 multiplied by x minus 3, 2 to the power of 5. That's a good one for you to know. That's 32. Okay, and you can sort of see how the question's going from here. Okay, so let's finish it off, shall we? So let's do 2x squared minus an x minus a 6x plus a 3 equals 32. 2x squared minus 7x. I'll take away the 32. It's going to give me minus 29 equals to 0. And I can get my answers from that. Okay, what will I need to make sure of when I do my answers? I will need to make sure that they work with these equations here. So let's just quickly have a go. I'm using the calculator for this one here because it doesn't say solve using algebra or anything like that. And I get 7 plus root 281 over 4. And I get 7 minus root 281 over 4. So what you've got to do now is you've got to check that they're okay with these things here. So that minus one, yeah, that minus one. So what was it? 7 minus root 281 over 4. Sounds like it's going to be a negative number to me. And it is. So that will not work. It will not work because it's negative already. If you do a negative number take away 3, it's going to break this one here. So this will not be valid. So we simply put a cross through it. Okay. And I'm going to test the other one. So the other one, this one here, this is about 5.9-ish. When I do 5.9 take away 3, that's still going to work. 2 lots of 5.9 take away, yeah, it's going to be fine. So you should find that this is the only solution to that equation above. Now let's try it one more time. So here we go. I'm going to have a go at this question here. So log of something, take away log of something. There's a few ways to do this question, but the general idea of my rule is log A minus log B is the same as log of A over B. Perhaps not too surprising. When you add, you multiply. When you divide, sorry, when you subtract, you divide. So let's do that now then. So log of x plus 1 over 2 equals 1. So check I'm happy with that. Yep. What do I do next? It's my 10 to the power of on both sides. I get x plus 1 over 2 equals 10. X plus 1 equals 20. X equals 19. Okay, so that's how we would sort of go about doing a question like this. So next time for yourself, just before you jump too far into the question, make sure that you are using your logs correctly. And when you do use them, don't forget to check that your solutions actually work with your equation at the start.